Okay, that cut me off just before the end. So where we were was right here. When you punch these numbers into your calculator for x, you get 2.326 meters per second. You look at the direction, oh, that's west. Then in the y, you punch in your numbers, you get 6.39 meters per second. Looking at the direction, that's north. You're done number 2. Now number 3 is exactly the same thing, just with a huge big story with it. So the hardest part of number 3 is reading all the jibber jabber. Hot air balloon drifted 60 kilometers east, 60 degrees north. So east, 60 degrees north. Here's my 60 degrees. Here's my 60 kilometers. It goes on and on about radio crew, bring me lunch, looking at the wildlife, etc. But really all it wants you to do, well, maybe there's no wildlife or lunch, but come pick us up. And all it really wants you to do is find the x and y. Exactly the same thing. Again, if you look at it, x is the adjacent side, so that'll be cosine. So cos of 60 degrees is equal to x over 60 kilometers. So x is equal to 60 kilometers cos of 60. Cos of 60 is the same as the sine of 30. So you end up with 30 kilometers east. Then you do the y. Sine of 60 is equal to y over 60 kilometers. So y is equal to 60 kilometers sine of 60. That's 0.866 times 60. 51.96 kilometers, direction north. They say stuff in the question about roads are, the intersections are every 2 kilometers, so I guess here they're going to have to walk 40 meters to get to picked up, but maybe they can handle that. All right, so today I would like you to try the questions on page 463, and here you need to draw them, okay? So and that's the hardest part. If you can get the drawings right, you'll be okay. So in number 4, it says a pleasure boat heads out of a marina for sightseeing. It travels 2.7 kilometers south. So here it is. This is 2.7 kilometers south. Then it turns and it goes south 26 degrees east for 3.4 kilometers. So here's my south. 26 degrees would be like this. Well, maybe it's a little bit too big, but... And this is 3.4 kilometers. And this is 26 degrees. Then it says it turns again, and this time it heads east 12 degrees north for 1.9 kilometers. So east 12 degrees north, so in here is 12 degrees, and this is 1.9 kilometers. Now your resultant, is right here. Whoops, if you could imagine that is straight. Clearly that's not a right angle triangle, but you can break these guys into their components. So find y2 of the 3.4 and find x2. And then you can also break this one into its components. This will be x3, this will be y3. And then once you do that, you should be able to see now it is a right angle triangle. You can just take your line across here, add up the y's, right? So add these two and subtract this one to get your total y. Add the x's, and then you can do the Pythagorean theorem. Okay? So number 4 should be okay. 5's a little trickier, just in drawing. So 5 says, a jet ski driver wants to head to an island on the St. Lawrence River that is 5 kilometers west, 20 degrees south. So if you're here, Buddy wants to go west, maybe I'll do it down here. If you're here, Buddy wants to go west 20 degrees south. So he wants to end up somewhere over here. He wants to do, this. Okay? But if you keep reading where this is 20 degrees. But if you keep reading, it says if the river is flowing east. So if he aims here, the river's going to carry him down here. he needs to aim further west. This is hard to draw a straight line without holding the paper. Okay, so he needs to aim somewhere up here and let the river carry him down. Okay? And so there's your triangle, really poorly drawn. If I could balance the camera, I could use, wait, maybe. Okay, so like if I do it back here, then again. So he wants to do this. He needs to aim here so the river can carry him this way. This whole angle right here is 20 degrees, this full thing. This is the river's velocity, 6 kilometers per hour east. It says with respect to the water, he can go 40 kilometers per hour. This is what he's doing with respect to the water, 40 kilometers per hour. And this is his resultant. What he's doing with the water plus what the water is doing gives him his resultant that ends him up where he wants to be. So if this is 20, that means this is also 20. So that means you should be able to get this angle in here. And then you can use sine law and cosine law to solve this, okay? Assuming you know the sine law, cosine law, A over sine A is equal to B over sine B is equal to C over sine C is the sine law. Cosine law is C squared is equal to A squared plus B squared minus 2AB cos C. Okay, so you're going to use these two for both number 5 and number 6. So I've drawn number 5 for you. You see if you can draw number 6. Okay, so finish these up. And assuming we see you tomorrow, we'll go over them then. All right, enjoy the rest of your day.